Welcome to Sir RP's channel. In this video, you are going to learn how to solve quadratic equations by completing the square. This is the second learning competency to be discussed in Mathematics 9. So, learn and love math with Sir RP. We have this most essential learning competency. The learner solves quadratic equations by extracting the square roots, factoring, completing the square, and using the quadratic formula. But for this specific session, we're going to discuss solving quadratic equations by completing the square. Are you ready to learn? Sit back, relax, and get ready to learn. Let's first define the term completing the square. It is a method for solving quadratic equations by changing an incomplete quadratic trinomial into a perfect square trinomial. To complete a quadratic equation means to make one of its sides a perfect square trinomial. What are the characteristics of a perfect square trinomial? A trinomial is a perfect square trinomial if 1. The first and third terms are perfect squares containing positive numerical coefficients, and second, the second term is twice the product of the square roots of the two perfect squares. So let us try to have the proof or the process in solving or completing the square. Given the quadratic equation in standard form ax squared plus bx plus c equals 0, the first thing that we're going to do is we isolate the constant. The constant here is c. So with this, we have ax squared plus bx equals negative c by addition property of equality. Next, simplify the given equation to reduce the coefficient of the quadratic term to 1. So if the value of a is not 1 or it's greater than 1, we're going to simplify it so that we can apply completing the square. So with that, we divide all the terms with a. So we have ax squared divided by a, bx divided by a, and negative c divided by a. Then we get the half of the coefficient of the linear term, and then we square it, then add the results to both sides. So this is the process. We have here ax squared divided by a, so we have x squared. Bx divided by a, so we have bax plus the square of the half of the coefficient of the linear term, then minus c over a plus the result of whatever is the result of the half of the coefficient of the linear term, and then it's a square. With this, we have x squared plus b over a times x plus the half of ba is we're going to multiply it by 1/2. Okay, so we have here ba times 1/2 is b over 2a. Then, according to the rule, we are going to square the result. In getting the square of the result, we have now b over 2a squared. Then, we add the results to both sides. So that is, we also add the same to the other side. Then by that, we need to apply the next step. We're going to express the perfect square trinomial as a square of a binomial. With this, we have x plus b over 2a squared equals negative c over a plus b over 2a squared. So this is the whole process in completing the square. Let's try to have it with our examples. Find the number that will complete this square for x squared minus 5x equals 0. We are just to complete the square. We are not to find the values of x. Here is the solution. The constant is already isolated to the right hand of the equation, and the coefficient of x squared is already 1. So we can see that the coefficient of the quadratic term is already 1. Therefore, to get the number that will complete the square, we get the half of the coefficient of the middle term. So the coefficient of the middle term is negative 5. Then we are going to square it. In our example, the coefficient of the middle term is negative 5. Thus, negative 5 divided by 2. Thus, negative 5 divided by 2, then we square it, we will get 25 over 4. Therefore, the number that will complete the square is positive 25 over 4. Let's try to have another example. Find the solutions to the quadratic equation x squared plus 4x minus 6 equals 0 by completing the square. Recall the steps or the process we had earlier. First, to find the solution to the given quadratic equation, we're going to apply the following steps. Since the coefficient of x squared is already 1, or the coefficient of the quadratic term is 1, we can now proceed right away to isolating the constant to the other side of the equation. With this, we are going to apply addition property of equality, or we transpose. So that is negative 6. So we now have positive 6. Then we proceed with the next step. Find the number that will complete this square. Add the number to both sides of the equation, then simplify the constant on the right-hand side. Remember, in completing this square, we need to first get the half of the linear term, the coefficient of the linear term, then we're going to square it and add the result to both sides. Okay, we have here the square of the half of the coefficient of the linear term. So we have x squared plus 4x, then 4 divided by 2 is 2, squared that is 4. Okay, so that is 4. Same with the other side, 4 divided by 2 is 2, squared that is also 4. With that, we simplify x squared plus 4x plus 4 equals 6 plus 4. And 6 plus 4 is 10. So we now have this equation. X squared plus 4x plus 4 equals 10. Remember that the next step is we're going to express the perfect square trinomial into a square of a binomial. In this case, we have here the perfect square trinomial, which is x squared plus 4x plus 4. Now, we are going to express it as a square of a binomial. Thus, we now have this square, x plus 2 squared equals 10. That is the square of a binomial of this expression, x plus 2 squared. So when we're going to solve for this, the result will be x squared plus 4x plus 4. We need to apply the next step. Extract the square roots of both sides of the equation to find the solutions. We're going to get the square root of both sides. So we have square root of x plus 2 squared is equal to positive negative square root of 10, because the value of k is greater than 0. So we need to use the positive and negative square root of that number. So with this, we have now the square root of x plus 2 squared is x plus 2. We just have it like this. Then positive negative square root of 10. The question is there a positive negative square root of 10? Okay, so there is none. So we isolate the x, then we get x is equal to negative 2 plus minus square root of 10. Therefore, the solutions to the equation, the x squared plus 4x minus 6 is equal to 0 are negative 2 plus square root of 10 and negative 2 minus square root of 10. And that's it. Let's try another example. Find the solutions of x squared plus 4x minus 12 equals 0 by completing this square. So we have, again, the first step is we're going to isolate the constant. So with this, x squared plus 4x minus 12 equals 0, we get x squared plus 4x equals 12. Please look at the colors of the terms or the numbers. Then we get the half of the coefficient of the linear term, or b, and we're going to square it. In this equation, the value of the coefficient of the linear term is 4. So we have 4. Then according to the step, for the process, we're going to get its half, and then we're going to square it. With this, 4 divided by 2 is 2. Then when we're going to square it, that is 4. Then step 3, we're going to add the results to both sides of the equation. We have x squared plus 4x plus 4 and 12 plus 4. Thus, we have x squared plus 4x plus 4 is equal to 16. From here, we're going to express the perfect square trinomial as a square of a binomial. In this case, the perfect square trinomial is x squared plus 4x plus 4. There is an easy way to turn the perfect square trinomial to a square of a binomial. Just remember the result in step 2. So we have x plus 2 squared is equal to 16. What are we going to add here? For us to get easily or express easily the perfect square trinomial as a square of a binomial is that we're going to refer whatever is the half of the coefficient of the linear term, we're going to add it to x and then square it. That is now the square of a binomial. So that's the easiest way. Then we apply the step 5. Apply the square root property. Property 1 because the value of k is greater than 0. With that, we take the square root of the 2. Then when the x plus 2 is equal to positive negative 4, then we simplify. We now have x is equal to positive negative 4 minus 2. Separate the 2 and then we get x is equal to 4 minus 2 and x is equal to negative 4 minus 2. So we have two answers. 4 minus 2 is 2 and negative 4 minus 2 is negative 6. And these are the solutions to the equation x squared plus 4x minus 12 is equal to 0. Let's have another example. Find the solutions of x squared plus 24x minus 25 is equal to 0 by completing the square. Again, just remember the steps in solving quadratic equations by completing the square. First, we isolate the constant. With this, the constant is 25. So when we isolate the constant, it will become positive 5 by addition property of equality. Then we get the half the coefficient of the linear term b and square it. We have the linear term, which is 24, divided by 2 is 12, and the square of 12 is 144. Then we add the result to both sides of the equation. That is x squared plus 24x plus 144 and 25 plus 144. And then we get x squared plus 24x plus 144 is equal to 169. From there, the step 4 is we're going to express the perfect square trinomial as a square of a binomial. Just remember the clue or hint I gave earlier that we just need to get or add whatever is the half of the coefficient of the linear term. So that is x plus 12 squared is equal to 169. From there, we apply the square root property. Take the square root of the two sides, we get x plus 12 is equal to positive negative 13 because square root of 169 is positive negative 13. Then we have now here x is equal to positive negative 13 minus 12. Or it can be interchanged. It can be negative 12 plus minus 13. Then we separate the two. We have 13 minus 12 and negative 13 minus 12. The answers are 1 and negative 25. And these are the solutions to the equation x squared plus 24x minus 25 is equal to 0. Let's have the fifth example. Find the solutions of x squared minus 5x plus 6 is equal to 0 by completing the square. We have now the steps. Isolate the constant. So that's the process. We now get x squared minus 5x is equal to negative 6. Then we apply the second step, getting the half of the coefficient of the linear term and squaring it. Considering that 5 is not perfectly divisible by 2, so we have here still negative 5 over 2. Then we take its square. That is 25 over 4. 5 squared and 2 squared, that is 25 over 4. Then we add the result to both sides of the equation. With that, we have x squared minus 5x is equal to negative 6. And at the result of both sides, we get x squared minus 5x plus 25 over 4 is equal to negative 6 plus 25 over 4. Then we add negative 6 and 25 over 4. That is 1/4. Then we express the perfect square trinomial as a square of a binomial. Again, just add whatever is the result of the half of the coefficient to the linear term. When it's negative, you're going to subtract because positive times negative is already negative. So we have x minus 5 over 2 squared is equal to 1/4. Next, we apply the square root property. So with this, we have x minus 5 over 2 squared is equal to 1/4. So taking its square root, we get x minus 5 over 2 is equal to positive negative 1/2 because square root of 1 is 1 and square root of 4 is 2. Then we simplify. We have x is equal to positive negative 1 half plus 5 halves. Separate the 2, we get 6 halves and 4 halves, and that is 3 and 2. Now to the last example. Solve the quadratic equation 2x squared plus 8x minus 10 is equal to 0 by completing the square. Considering that the value of a is greater than 1, remember that we need to reduce it first for us to apply completing the square. We simplify both sides of the equation by dividing 2. So we have x squared plus 4x minus 5 is equal to 0. Then we isolate the constant. That is x squared plus 4x is equal to positive 5. Then the next step, get the half of the coefficient of the linear term and square it. That is 4, because 4 divided by 2 is 2 and 2 squared is 4. Then we're going to add the result to both sides. We have x squared plus 4x plus 4 is equal to 5 plus 4. That is x squared plus 4x plus 4 is equal to 9. Then express the perfect square trinomial as a square of a binomial. Again, just get the half of the coefficient of the linear term and add it to x. That will now form the square of a binomial. So we have x plus 2 squared is equal to 9. Take the square root of the two sides. We have square root of x plus 2 squared and positive negative square root of 9 since k or 9 is greater than 0. So that is x plus 2 is equal to positive negative 3. We now have x is equal to positive negative 3 minus 2. Separate the 2. We get 1 and negative 5. And that ends the examples for completing the square. If you have questions, feel free to comment it in the comment section. Now, let's try to go back to our competency. The learner solves quadratic equations by completing the square. This is our focus. Ask yourself, did you achieve the target, or were we able to meet this learning competency? The answer depends on you. So for our activity, we have here find the solutions of each of the following quadratic equations by completing the square. First, x squared minus 2x is equal to 3. Second, 4x squared minus 32x is equal to negative 28. For your answers, please use the comment section. And that ends our session for today. Thank you, Quipper, for the slides used in this presentation. Once again, thank you and happy learning. Don't forget to subscribe and click the notification button to receive updates. This is Sir RP.